Hi everyone, we still in the chapter 4 and we will end it today with this section entitled Further Coordinate Geometry. Normally, it is all about using the previous sections information that we explained before in further calculation in the geometry space, okay, the geometry subjects. So first of all, we have a triangle PQR with the coordinate of each point. P with coordinate 1, 0, Q 3, 1, and R 0, 4. Okay, we want to find the length of each side. It is very easy to find the length of each side. Trivial, because we use this equation. The distance between the point PQ, it is this big radical, x minus x squared plus y minus y squared. PQ, 1 minus 3 squared, so minus 2 squared, 4. 0 minus 1 power 2 is 1. So normally we are talking about radical 5. And the same for the others. So we calculate the distance between PQ, PR, QR. So these segment lines have different lengths. So when we have a different lengths, we can based on these lenses to classify the triangle. So we can use the side lenses to classify the triangle. So we are talking about triangle, scalene triangle, because all sides have different lenses. But if, for example, we have two sides are equal, so normally we are talking about isosceles triangle. If all sides have the same length, so we are talking about equilateral. And if we can apply Pythagorean theorem. What we mean by Pythagorean theorem? So the largest line here, if the largest one squared equal to the sum of the squared of the other sides, because we have 3 sides, okay? So normally if we apply easily the Pythagorean theorem, so normally we are talking about right angle triangle. Easy also to do by yourself the exercise 2 to assess your information. So normally how to classify this triangle. First of all, we search for the length of LM, the same way as we did before. LN and MN. Okay, and we compare these lenses and we state and we classify our triangle based on this information. We have a triangle ABC, and with these vertices, so we find the length of, how to find the length of the line segment from A, we have its coordinate to the midpoint of BC. Midpoint, so we need to know the coordinate of the midpoint. Easy to use this one. So because we know that the midpoint of a segment line, xi, is equal to the extreme, the abscissa, the sum or the average of the abscissa, xb plus xc over 2, and y of the midpoint equal to yb plus yc over 2. These are rules and formula to memorize and to know how to apply correctly, properly. So we found the coordinates of the midpoint of BC. So we use these coordinates with the coordinates of A in the equation, the distance radical x minus x plus y minus y squared equal to what we are searching for. In the fourth exercise, by finding the equation of line AB and substituting the point C, show that points are lying in the same line. Okay, how to find the equation of a line? Easy. Plot y-intercept or another inspection to find the line. So slope y minus y over x minus x. And please be aware about the order BB, AA. Easy, we obtain the gradient. So we search for the y-intercept, the small b, by substituting for example, the point C. Sorry, one of the particular point A or B to find the line, the equation of the line AB. Or we can use y minus yb, y minus y equal to 3x minus xb, or 3x factor x minus xa. Finally, we obtained our equation y equal to 3x minus 5. The small b is minus 5 here. So how to verify that the C belongs or lies on the same line? So we verify if the coordinate of C verify our equation. So we'll obtain 7 equal to 7. So there's a true statement. So yes, we can say true, then, sorry, C lies on the line with A and B. Okay? In the small b, we follow the same step as in part A. Moving on to the next exercise, we have line segments AB and CD bisect each other at T. Using A and B, find the coordinate of the midpoint B. Normally, T is the midpoint of the line segment AB. Midpoint, easy. We use the formula of midpoint because T is the midpoint of AB, so XT and YT equal to the average of abscissa of AB and the average of the ordinate of AB. And then we can use, but in different way, we can use the coordinate of the midpoint T when T is the midpoint of the line segment CD to find the coordinate of C. Okay, easily we find that C has a coordinate 0, 2. Okay. Another way to classify our triangle, we can base on the angles of this triangle. If all angles in a given triangle have different measures, so we are talking about scaling. If two angles are equal, we are working in an isosceles triangle. And if all the angles are equal, what we mean by all the angles are equal, we know that the sum of angles in any triangle equal to 180. So 180 and all the angles are equal. So we are talking about x plus x plus x equal to 180. So normally are equal to 60 degrees. So we are talking about equilateral triangle. If one of the angles equal to 90 degrees, so or we can say easily we have two perpendicular sides in this triangle, so we are talking about right angle triangle. So you can assess your information using this one to find the solution of this exercise, easy to calculate or to solve. Okay. First of all, we have these three vertices in a given triangle, and we want to find out if it is right angled or not. Okay, we find the sides DE, DF, and DF. We obtain the 3, 4, 5. I want to ask you which length, which side has the longest measure? Normally this one, EF. So to find out if we are working in a right angle triangle, we should know if we can apply Pythagoras theorem. Pythagoras theorem say longest side equal longest side squared. So 5 squared, because we know that the hypotenuse is the longest side in the right angle triangle. So the longest, we mean the hypotenuse square. Okay, hypotenuse is the side opposite to the perpendicular. This is the hypotenuse, the longest one. Okay, 5 square equal to the other sides. the sum of the square of the others. If the statement is cool, is true, so normally we are in right angle triangle statement. So normally 5 squared equal to 4 squared plus 3 squared, true. So yes, DEF is right angle triangle. Where? At which angle? Which angle? Which vertex? The EF is the hypotenuse. EF is the hypotenuse. So the other vertex, the remaining vertex is the principal angle, the right angle. The right angle triangle. Okay, the right angle. Okay, so normally EF is the hypotenuse. So D. So this triangle is right angled at D. Easy. And in the following exercise, I gave you a hint. Very easy. And also for the remaining exercises. So these are the main idea of the chapter. We ended just chapter 4, and we will start, inshallah, soon with the chapter 5. Thank you for listening. Have a nice day.